We are moving on to section 4 of chapter 2. It is about the chain rule. So far we have taken the derivative of simple functions. They were not complicated. Just we had the sum, difference, product, and the quotient rules, and they were pretty much simple. Now when we are talking about the chain rule, we've got the fog function, okay? We have got fog of x. That means we have got something complicated, a function that is inside another function, and we have to take the derivative of that one. How do we take that derivative? That's the first derivative. How do we take that derivative? It is equal to f prime of g of x. Of course, when we come to the examples, it would be much more easier for you to understand what do we mean by f prime of g of x. And then we are multiplying it by the derivative of inside. Okay, so we are taking the derivative of the whole function at the first, and then we are multiplying it by the derivative of inside function, which is g of x. In general, if you have got the general power rule, okay, let me write it, general power rule, that is mostly you're using this one. If you have got f of x to the power of n, and I want to take the derivative of this one, okay, I have got a function to the power of n, and I want to take the derivative of this one. How can I take that derivative? It would equal to n multiplied to f of x to the power of n minus 1 multiplied to f prime of x. If you remember from the previous sections, when we had a simple function, for example, f is equal to x to the power of 3, how were we taking the derivative of this one? We were simply saying that 3 comes in front, okay, x to the power of decreased by 1. Here, instead of that x, we have got a function to the power of n, okay? So if you have got, for example, f, that's equal to g to the power of 3. How do we take that derivative? The derivative of this one is equal to 3g squared. But here, instead of the x, I have got g, so I will simply take the derivative of g also, okay? That's not 9, okay? It's g. So if instead of x, I have got something else to the power of 3, again, I'm doing the same procedure that I was doing for differentiating a simple function. I'm taking the 3 down, decreasing the power by 1. Only thing that makes a difference here is I'm multiplying that derivative with the derivative of g inside of the bracket. Let's take an example. Find the derivative of this one. Let me say that is 2x plus 1 to the power of 5. Okay. If you have f that's equal to x to the power of 5, how do you take the derivative? It is 5x to the power of 4. Here, instead of x, I have got 2x plus 1. It's like the g. Look, here I have got x to the power of 3. Here I have got g to the power of 3. Here I've got x to the power of 5. Here I have got that bit to the power of 5. So how do I take the derivative of this one? Again, we said we are considering this one all as g. So I will take the derivative as it is 5 to x plus 1. This is the g, okay, to the power of 4. Look, 5 came in front, the n came in front, and that is the function that I have got g, and the power is decreased by 1. And what else do I have to do extra? I have to take the derivative of g also. That is the g, okay, or that is the g. It's like this one. I have to take the derivative of g also. What is the derivative of g? That's equal to 2, okay, 2, that's 0, so it is 2. 5 multiplied to 2, that's 10. 2x plus 1 to the power of 4, and that's the derivative of fog function, okay? Let me give you another example that is in your course material. Example, it's required from you to differentiate y, that's equal to x squared plus 3x plus 2 under this square root. Let's first think about the derivative of y if it is equal to root of x. If you remember that, we were first changing this one to a power, okay, y equal to x to the power of 1 over 2. We were changing the square root into a power, and then we were taking the derivative. That was 1 over 2 x to the power of 1 over 2 minus 1. So that one is equal to 1 over 2 x to the power of minus 1 over 2, and that's equal to x comes down because it is negative sign and the root is x to the power of 1 over 2. Okay, we were doing it like that if x was given to us. How about if instead of x I have got that monster inside here? It doesn't make a difference. You're doing the same procedure. Okay, you're saying that monster to the power of 1 over 2 instead of x 1 over 2. So first I'm changing that function. Okay, I'm only changing it from square root to a power, x squared plus 3x plus 2 all to the power of 1 over 2. Okay, x to the power of 1 over 2, monster to the power of 1 over 2 is the same thing. I'm doing the same procedure, taking the derivative. What did I do here? I took this one in front and decreased the power by 1. I will do the same thing here. I will take 1 over 2 in front and decrease the power of monster by 1. Okay, 1 over 2 minus 1. It doesn't make a difference, x or that function. Okay, let's do this one. 1 over 2 x squared plus 3x plus 2. 1 over 2 minus 1. 1 over 2 minus 1 is equal to minus 1 over 2. But I have got something else here when I'm taking the derivative. Sorry, here also. Okay, when I'm taking the derivative of monsters instead of x, I have to also take the derivative of the monster. Okay, this one is this one to the power of that. I took the derivative and I also have to take the derivative of that bit, multiplying to it. That's the g given in here. Okay, that's the g. So I have to multiply it with g prime. What is g prime? It's equal to 2x plus 3. The derivative of that bit, it's g prime. Look, here we have got multiplying it by g prime, so g prime here is equal to 2x plus 3. Here we also have got 2x plus 3. Now I have got 1 over 2. This one is negative, it makes it upside down. 1 over 2 changes the thing that I have got back to square root, so that is x squared plus 3x plus 2. Okay, multiplied to 2x plus 3, and that is the required result. So that is the derivative of fog. If you have got a complicated function, instead of having only x as x to the power of 5 or x to the power of 6, x under the square root, x under the cubic root, we will have instead of x another function to the power of those things. And the only thing that is different here is you have to multiply that derivative with the derivative of inside. Okay, with the derivative of ناو كوانا هاد دا تشراوي نخشة كور دقري وكرتي دا تشراوي ناو كواني دكي من ناو كوانا كيا. Okay, I think we have got another example also. Again, it's required from you 2.4.5. Y is given to you as 1 over 2x plus 3 to the power of 5. Again, it's required from you to find y prime is equal to what? First, we have to change this one to a power function. I'm rearranging it. That would equal to 2x plus 3 to the power of minus 5. The 5 goes up to the numerator, so that would be x to the power 2x plus 3 to the power of minus 5. Now let's differentiate it, y prime. Let's go back to the first section, second section. If I have got y to the power of, it's like 1 over x to the power of 5. Okay, instead of the x I have got 2x plus 5, and then I'm changing this one to a power like this. How do I take the derivative of this one? That would be minus 5x to the power of minus 6. Okay, so I will do the same procedure here. It will be minus 5. Instead of x I have got 2x plus 3 to the power of minus 6, decreasing the power by 1. But I have got something else here also. Okay, instead of that, leaving it alone, I have to multiply it with the derivative of inside the bracket. What is the derivative of inside the bracket? That's equal to 2. So that one is equal to minus 5 multiplied to that is equal to minus 10. That minus takes it to the denominator, so that would be 2x plus 3 to the power of 6, and that is the required. We have got example 2.4.6. That example says differentiate the function f of x that's equal to 3x plus 1 to the power of 4 multiplied to 2x minus 1 to the power of 5. Then find all values of x for which the tangent line is horizontal. We said from the previous example, when it says the tangent line is horizontal, that means m is equal to 0. That means the first derivative is equal to 0. Okay? So, how can we find the derivative of this one? First requirement, derivative. This one is a multiplication of two functions. That's the f function, and that one is the function g. These ones are multiplied together. So we have to write first one's derivative. The derivative of f is equal to what? Derivative of f is equal to 4 multiplied to 3x plus 1 to the power of 3. Okay, 4 comes down, 4 is decreased by 1, it's 3, and then multiply with the derivative of inside, that's equal to 3. Derivative of this one is equal to 3, and then multiply it to g. What is g? G is equal to 2x minus 1 to the power of 5 plus derivative of g multiplied to f. What's derivative of g? That's equal to 5 2x minus 1 to the power of 4 multiplied to 2, the derivative of inside, and then multiplied to f. F is equal to 3x plus 1 to the power of 4. Okay, so first one's derivative, f, the derivative of f multiplied to g plus the derivative of g multiplied to f. Okay, let me write it for you. This one is all f prime, and that one is g, and that one is g prime multiplied to f. Now let's do simplification. 4 multiplied to 3, that's 12. 3x plus 1 to the power of 3, 2x minus 1 to the power of 5, plus 5 multiplied to that one is 10. 10 multiplied to 2x minus 1 to the power of 4, and here we've got 3x plus 1 to the power of 4. Look, I just simply multiplied this one and put this one and that one as it is, multiply this number with that one and put this one and that one in its place. Now we are taking common factors. You see that we have got one term here and another term here. You see that there is something common between this one and that one. From the numbers, what do you see common? I can take out 2 as common. Okay, so I will write 2. That's common between 12 and 10. Now from this part and that part, 3x plus 1 to the power of 3, 3x plus 1 to the power of 4. So I have got 3x plus 1 to the power of 3 common between this part and that part. It's like you have got 3 apples here and 4 apples here. How many is common between them? 3 of them are common, so I'm taking it out. Now I have got 5 oranges here and 4 oranges there. How many of the oranges are common between this part and that part? 4 of them are common, so 2x minus 1 to the power of 4. Now I'm opening a big bracket, okay, to see what's remained in this part and that part. What's remained from this one? I took 2 out, 6 remains. Why? Because 6 multiplied to 2 is equal to 12. I took the 3 apples out, so no apples are left here. And I took 4 oranges out from here, so that one is equal to 2x minus 1. Only 1 remains here. Now I have got the positive sign. Again, I have taken all the 4 of them out. And from the 10, I have taken 2 out, so 5 remains because 5 multiplied to 2 is equal to 10 again. And then 3x plus 1 is remained in that part because I have taken 3 of them out, only 1 remains here. Needs further simplification, so that one is 3x plus 1 to the power of 3, 2x minus 1 to the power of 4, and in that bracket you have to multiply this one to both of them and this one to both of them. You will get 27x. You will do that multiplication, okay? That would be 12x plus that's equal to 15x. You would add them, that will be 27x, okay? Minus 6 plus 5 is equal to minus 1. So that remains from the bracket. Now this is only the first derivative of the function, okay? That's only the differentiation. Then what's required from us? It says find all values which the tangent line is horizontal. What does horizontal mean? That means the first derivative equal to 0. Okay, sorry. So the second requirement, it says tangent line is horizontal. Okay. What does that mean? That means y prime is equal to 0. So we are simply putting this one equal to 0. So I will get that one is all equal to 0. 2 multiplied to 3x plus 1. Okay. To the power of 3, 2x minus 1 to the power of 4, 27x minus 1, all equal to 0. I have got this multiplied to this multiplied to that is equal to 0. So either this one is equal to 0, or that one is equal to 0, or this one is equal to 0. So 3x plus 1 is equal to 0. Of course, to the power of 3, we can also write it, but I'm simply writing it without power of 3, because later you have to take cubic root for both of the sides, and still you will get that one. Or 2x minus 1 is equal to 0, that one, or 27x minus 1 is equal to 0. So from here, I will get, taking this one to the other side, it will be minus 1. So x is equal to minus 1 over 3. Okay, take this one to the other side, it will be minus 1 divided by 3. It will be x is equal to minus 1 over 3. And x is equal to, if I take this one to the other side, it will be 1. Dividing it by 2, it will be 1 over 2. And here x is equal to, I'm taking this to the other side, 1 over 27. So when x is equal to, when x is equal to 1 over 27, x is equal to 1 over 2, or x is equal to minus 1 over 3, the tangent line of that curve would be horizontal, a straight line with slope equal to 0. That is all about that section. Okay, you've got another example. It's required from you to find the second derivative of a quotient function. I will leave that one for you because it's just the application of the rules that we have studied from the quotient rule and the Fogg function. So that would be easy. I will skip this one for you. In general, for those two sections, we have studied product rule, quotient rule, higher order derivatives, and the chain rule, the derivative of complicated functions. That's all for that section also. Hope you would understand everything, and of course, if you've got any questions, you're free to ask, sending emails, or however you would contact me. Have a good time, and bye-bye.